thing I think it's useful to do here is to put missing measurements onto the diagram. So they tell us, first of all, that OA and OB are both 37. So I'm going to put another 37 there. OC is 40. CA and CB are both 20. So I'm going to put another 20 over there. AB is 24, which means that this distance is 12, and this bit here is also 12. And the first thing that it asks me to do is work out the length of OM. And I usually find it's easier here to redraw the triangles from the front, because it usually makes it a bit easier. So I can see that that's 37, that's 37. If I want to find OM, what is important here is that that's a right angle, and this distance is divided in two, so that that's 12 and that's 12. So here's M and here's O, so I can see that OM squared by Pythagoras is 37 squared minus 12 squared. If we figure that out, it comes out as 1,225, and if we find the square root of that to find OM, it comes out as 35 centimeters. So I'm going to put that on the diagram. So this is 35 now. Okay, next thing it asks me for is CM. Okay, now in order to work out CM, I'm going to draw the base triangle. So here we have C, there's M, which is exactly in the middle. So again, that's 12 and that's 12, and these are both 20. And again, this straight line here, CM, there we have a right angle. So again, CM squared is going to be 20 squared minus 12 squared. So 20 squared minus 12 squared, which comes out as 256. And if we find the square root of that, we find that CM is 16 centimeters. So this distance here is 16. Okay, it now says what's the angle between OC and the base. Now here's OC, the base is here, and the angle that we need between OC and the base is actually going to be this angle, OCM. So we want angle OCM. And in fact, if I just draw the triangle that we need, here's O, here's C, here is M. The angle that we need is this one here, which is theta. CM we've just established is 16. CO is 40. OM we've just discovered is 35. So we have a triangle here where we know the length of all three sides. So I'm going to be using the cosine rule to find the value of theta. Now, to make my life a little bit easier for myself, just for now, I'm going to relabel the triangle ABC just so that it makes it slightly simpler. So the angles are capital ABC. This is side C, this is side A, and this is side B. And the cosine rule for finding an angle says that cos C is equal to A squared plus B squared minus C squared divided by 2AB. Quote the formula, then we'll put the values in. You must learn this formula. A squared then is going to be 16 squared plus, and then B squared is 40 squared minus the 35 squared, and that's divided by 2 times 16 times 40. Now if we work that out, that comes out as 631 divided by 1,280. So the angle C is going to be the inverse cosine of that, or cos to the minus 1 of this value. So it's 631 over 1280, and that comes out as 60.4641 degrees. Now what I'm going to do is save that into my memory, because I've got a feeling that we might need to use that later. Anyway, for the angle then, I'm going to round it. I'll give my answer as 60.5 degrees, but I've got to be careful if I use that later to actually use this value, the exact value that I've saved in my memory. Now for the tricky bit. Okay, now we're asked to find the volume of the whole pyramid. And they give you the formula here, which is a third times the area of the base times the height. Now, height, we have to be very, very careful. The height for a pyramid always refers to the perpendicular height. So the height which is at right angles to the base. And we haven't got that yet. This is why this is worth quite a few marks. Okay, base area though, we can work out simply enough. The area of the base, well, the base is this ABC at the bottom. And if I just draw it again from above, okay, we've got 24 centimeters there. We know that this is 16. Okay, so this is just B, this is A, and this is C. So the area of the base is actually just going to be half the base times the height. So it's a half times 24 times 16. Well, that's just half of 24 is 12, and 12 times 16 comes out as 192 centimeters squared. So we know that the base area there is just going to be 192. Now, the tricky part is this height, the perpendicular height. And if I just show you where that's going to be, I'll just draw a straight line. But let's just do it in a different color. The perpendicular height is the height which is at right angles to the base, and it's going to be about there. So that what we actually have is a right angle here. Okay, now what we've already established is that this angle here is theta that I had before. So that was the 60.46. So this angle here is 60.4 degrees. And if I just have a look at this triangle here, this triangle, the height that I need, let's call that height. Okay, the height that I need is this distance here. And I can actually use the triangle here so that that's 40 centimeters, that's O, that's C, and this is height, so that that is a right angle, and this then is my 60.4 or so degrees. Okay, so I can use normal SOHCAHTOA trigonometry now, where this is the opposite, and this is the hypotenuse. So I now know that sine of my 60.4 that I've saved in my memory degrees is equal to the opposite, or that's the height that I'm looking for, divided by the hypotenuse, which is 40. So the height of my pyramid has to be, so the height is going to be 40 times sine 60.4 blah 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 degrees, and that comes out as 34.8018 centimeters. So the height of my pyramid is 34.8018. So now to find my volume, let's just go back to here. So my volume is going to be a third times the base area, which is the 192, times the perpendicular height, which is 34.801. La 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 la. If I multiply those together, it comes out as 2,227.3203, which I'm going to round. I mean, I could round it to three significant figures, so that'd be 2,230. That would do, centimeters cubed. Or you might like to give it to the nearest centimeter cubed, which would be 2,227 centimeters cubed. Either of those are fine.